So -3 is less than or equal to a, which is less than or equal to 2. For the record, for those of you who are just joining us, I just want to say that what this means, and this one too, similarly, a is between -3 and 2, inclusive of -3 and 2. Okay, so another way of saying this is that a is between -3 and 2 inclusive. Okay, that means that a could be -3. It could also be -2.5. It could be 0. It could be 1, 1.5, or 2, and a lot of other numbers in between there. It didn't say integers or anything, so decimal numbers are up for grabs here. Likewise, this one says that b is between, again, just the best way to read this, b is between 2 and 4, also inclusive. I say inclusive because of the or equal to signs here, okay? If you blank out, for instance, this part, it says a is greater than or equal to -3. If you blank out this part, it says a is less than or equal to 2. Without either of them blanked out, both must be true, and that's where we get the idea of being between. So that's just your quick primer on how to deal with these little symbols. Remember, the alligator eats the bigger side, okay, and points at the smaller side. That kind of thing. So hopefully you're kind of up to date on inequalities and how they work. But now it comes down to the quantitative comparison question. Whereas quantity A is the letter A minus the letter B, or rather the number that they represent, and quantity B is simply 1. Time to do some experiments. What's something between -3 and 2 inclusive? Well, 0 and 1 are inclusive, but you know I'm not a big fan of using those. Perhaps I'll use A equals -1. That is between -3 and 2. What is between B? What is B between 2 and 4, right? Inclusive. Well, the number 2 is, so I could say B equals 2. What then is quantity A under this condition? A minus B is then -1 minus 2. -1 minus 2 is -3. Okay, so -3 is less than 1, and that would imply that quantity B is greater, but is that conclusive enough? Can we say that this is always the case? Is there any ambiguity here? Well, we know there are other options besides -1 and 2 for A and B, respectively, so we better try something else. But to minimize our trial and error, let's think about what we can do to change this. What would we like to see, or what would we like to disprove? We already have that quantity A is less than B, okay, is less than 1. How could we raise this if we can? Could we raise this to the point where it's equal to or greater than 1? We can minimize our trial and error by saying perhaps that A is equal to 2. That would be the biggest possible number for A. Likewise, we could say that B is equal to 2. That is also within the constraints of the problem. And why have I picked these numbers? Because we're supposed to do A minus B, and I'm reasoning that the biggest possible number we can get from this is from doing the biggest number for A and subtracting the smallest number for B, at which point we get 0. Which means we're pretty much concluded. No matter what I do here, it's always going to be the case that quantity B is greater, because I can't get this difference to be greater than 1. It is at most 0, and otherwise negative.